Hello everyone, let's start learning dental material. I am Dr. Riddhi Lalan, author of Dental Material Mind Map book and also a prosthodontist who's going to guide you to learn dental material in a fun and easy way. So today we shall be talking about thermal properties of dental material. Let's start with the definition. It is defined as response of a material to application of heat. So what is important here to understand is that there will always be heat that is going to elicit the response. There are three important topics that we are going to cover today, and those are thermal conductivity, thermal diffusivity, and thermal expansion, with a short subtopic which is coefficient of thermal expansion. Thermal conductivity is defined as rate at which the heat flows through material over time. So what you see here is the flow of heat over time, which is dependent on transfer of heat. There are two types, okay? It can either be an insulator or it can be a conductor. So whenever a dental material is going to act like a conductor, the thermal conductivity is going to be very high, whereas a insulator is going to be a poor conductor of thermal energy or heat. Moving on to another topic, that is thermal diffusivity. So now we know the rate at which, the speed at which the temperature is going to transfer. Do you see Tom and Jerry here? Yes. So do you see the Tom is entirely heated up, but the handshake, the rate at which the heat is going to transfer into Jerry. I'm also drawing one diagram, and this is the surface from which the heat is being transferred. So this rate of transfer of energy is the thermal diffusivity. Another very interesting topic here is thermal expansion. How do we define it? It's basically the tendency of a matter to the change in shape, area, volume, and density. Four terms in response to change in temperature. Again, it's a thermal property, right? So there is going to be a change in temperature. Now, what I want you to understand is that change in temperature, like increase in temperature, would mean that there is going to be increase in kinetic energy. And this increase in kinetic energy will lead to increase in vibrations. Increase in vibration will ultimately, so imagine something is vibrating, right? What is it going to do? It's just going to increase the interatomic space. So basically, this increase in kinetic energy would mean that there's going to be elongation of material. So increase in any length will be correlated with heat, and cooling will show contraction. Moving on to the last important topic, which is coefficient of thermal expansion. So it is basically defined as change in length per unit original length. Also, can you let me know where have we actually read this? Yes, it was somewhere related to stress and strain graph. Beneath that, we had learned about strain, which was actually denoted by delta L upon L. But here I want you to see that it is on raising temperature by 1 degree Celsius, which is actually important, or else it will be just a simple strain. Now, there are various types, okay? So there is something known as linear, aerial, and volumetric. Linear is seen in solids, while volumetric is seen in liquid and gases. One of the classic example is enamel being having same coefficient of thermal expansion like that of the porcelain. This is important neat point of view, so please note it down, and also do not forget to revise the topic that has pinned onto it. Alright? Okay, so let's quickly go on to the MCQ. This is a clinical scenario that we see here. Alright? It says a patient receives a large class 1 restoration. A few weeks later, they complain of sharp pain when drinking hot coffee and cold water, which is related to temperature. So because there is temperature that has come into picture, we will consider that there is some thermal property that needs to be considered here. Now radiograph shows there are no recurrent caries but marginal gap. So one of the significant finding is marginal gap and visible at tooth and restoration interface. The most likely material property Responsible for this failure is, so option A, high thermal diffusivity of restoration is related to the rate of transfer of heat. It is nowhere related to how heat has transferred or how it will react at the marginal gap that is observed. So this is cancelled. Moving on to option B, mismatch in coefficient of thermal expansion. So we know there is a marginal gap. So there is a possibility that this mismatch would lead to contraction at different rates. Hence, this can be a correct answer. 3, low thermal conductivity. Now, if the conductivity is low, it is very well understood that it's not actually going to transfer heat. Again, that's a wrong option. And high specific heat capacity of restoration, it means that the restoration can bear high amount of heat change. Again, this does not support the answer, and hence B is the correct answer. Marginal leakage along with mismatch in coefficient of thermal expansion led to the pain. Moving on to the flashcard. Difference between thermal conductivity and thermal diffusivity. So it's very easy, right? Thermal conductivity is how well a material transmits heat, and diffusivity is the rate at which the heat is being transmitted. If you enjoyed solving the MCQ and flashcard, you should definitely go check out the app because there are more such MCQs and flashcards along with mind map, videos, and notes. And don't forget to like, share, and subscribe. And I'll see you in the next video. Bye.